Hi everyone, this is Dr. K. Kannan, faculty from EC Department, R.M.K College of Engineering and Technology. So in this video lecture, I am going to talk about the introduction about optical fiber communication. In particular, I am going to discuss about the types of optical fiber. So the optical fiber classified into three different types based on the material. That means the raw material which is used for the optical fiber communication is glass fiber and plastic fiber. And another one in terms of modes of propagation, where we have a single mode fiber and multi-mode fiber. Then based on the refractive index, we have step index fiber and graded index fiber. We will see one by one. So in step-index fiber, the refractive index of the core is uniform throughout and undergoes an abrupt changes at the core cladding boundary. That means the refractive index of the core for the entire length is uniform. Uniform means that it is constant, and the refractive index of the at the nearby core cladding interface is going to change. So nearby core cladding boundary it should be changes. The refractive index profile n of r is given by is n1 where r is less than a. That means within the core, and which is equal to n2 r is greater or equal to a, that is in the cladding. So the refractive index of the core we can represent in terms of n1, and the refractive index of the cladding we can represent in terms of n2. So the diagram shows that this index fiber structure. Here, the radius is represented from minus a to plus a. From minus a to plus a, the refractive index n1 is constant, and above plus a and above minus a, it's n2, it is a core refractive index. Then in the right side, you have one more diagram that represents optical fiber construction. So internally, you have core over which we have the cladding, and over the cladding we have buffer coating. So core, cladding, and buffer coating. The diameter of the core is about 50 to 200 micrometer in the case of multimodal fiber, and 10 micrometer in the case of single mode fiber. So the single mode fiber diameter it is 10 micrometer, and for multimodal fiber it is from 50 to 200 micrometer. And the lower bandwidth and the lower attenuation is possible. The light ray propagation is in the form of meridional ray, that is zigzag path, and it passes through the optical fiber in the axis. Now look at the diagram where we have two things. One is monomode step index fiber and multimode step index fiber. So in monomode step index fiber, diameter is given. For core it is 8 to 12 micrometer core and 125 micrometer cladding. So like that we have the multimode fiber. In multimode fiber, diameter it is 2a. So the diameter of the multimode fiber is higher than the diameter of the monomode step index fiber. Then single mode step index fiber is the only one ultramagnetic mode, and the core diameter in the order of 2 to 10 micrometer. So in single mode step index fiber, only one ultramagnetic mode is possible. And in single mode fiber, the intermodal dispersion, that is broadening of the transmitted light pulse when it is propagating, it is very low compared to other types. And the attenuation is very less when you go for the single mode fiber, and the tolerance requirement on optical fiber connector is very less. And this in the single mode fiber we can achieve maximum bandwidth possibilities, and the numerical aperture is maximum. So because of that, we are going to have the easier coupling to the optical source with larger core diameter. These are the main advantages of single mode fiber, or we can say mono-mode step index fiber than any other mode. Then we have multi-mode step index fiber. A multi-mode step index fiber has a core radius A and a constant refractive index N1. So N1 is a constant for the entire length, and a cladding of slightly lower refractive index N2 surrounds the core. Here the diameter of the multi-mode step index fiber is 50 to 200 micrometer, and the bandwidth is very less compared to single mode, and light propagation in the form of zigzag path along the fiber, and this will be applicable for short distance communication. And here the dispersal is maximum than the single mode fiber, and because of that dispersal the performance is very low. Now look at the diagram where the signal getting propagated inside the fiber of multiple modes, so more than one path taken by the light ray. So look at that, there is one, two, three, that is a one ray, and another one it is 4, 5, 6, that is another ray. So two modes according to this diagram. So more than one mode is called a multi-mode step index fiber. Then we have graded index fiber. The name itself says that it's a gradually varying of the refractive index. So the refractive index of the core is made to vary gradually such that it is maximum at the center of the core. Now look at the diagram, it is maximum at the center of the core. The diameter of the core is about 50 micrometer in the case of multimodal fiber. The path of the light is helical in manner, or we can have the spiral form. inside the optical fiber. So here the attenuation is very less and the bandwidth of the fiber is maximum, higher bandwidth. Here the light propagates in the form of skew rays and it will not cross the fiber axis. The skew ray, in skew ray, the ray path it is in and around the axis, not in the axis. Now look at the diagram. So that represents the N of R refractive index profile. So N1 represents the core refractive index and N2, N3 it is a cladding refractive index. So N2 equal to N3. So here the alpha value is equal to 1, that is represents the triangle profile. When alpha equal to 2, then it is called a parabolic profile. When alpha is more than 2, that means equal to 10 or more than or higher value, then this gradient index fiber is converted into step index fiber. Then the profile value we can represent in terms of gradient index fiber, it is N of R. So N of R, the radius from 0 to A, the core radius from 0 to A, we have the refractive index of N1 of 1 minus 2 del of R by A whole power alpha whole power 1 by 2. So here N1 it is a refractive index, del it is a relative refractive index difference. So del equal to N1 minus N2 by N1, and on R it is a radius and A it is the radius of the core and alpha it is the profile parameter. So if alpha equal to 1, as I told you, it is a triangle profile, and alpha equal to 2, then it is called a parabolic profile. When alpha equal to infinity, then it is called a step index profile. So where 0 to A, this is the equation, and above the A, that means R is greater than or equal to A, that is just like equal to the N2 cladding refractive index. So that can be indirectly we can represent N1 of 1 minus del, or that will be equal to this equal to approximately equal to N1 of 1 minus 2 del whole power of. So this represents the refractive index profile of graded index fiber. So look at the diagram, gradient index fiber where core and the cladding, so inside that core axis will be there. So fiber length is given. So the radius of the core, right? The radius of the core we can represent A and the diameter is 2A. Now look at that intensity profile. So at the center of the axis, the refractive index is maximum, and if you go away from the axis, then the refractive index is minimum. That is called the gradient index fiber. Then look at that gradient index multimodal fiber. What you have seen in the previous slide, it is single mode fiber, but here it is multimodal fiber. Gradient index multimodal fiber. So more than one ray can transmit at a time. So ray transmission of multimodal gradient index fiber. Core and cladding. So radius it is A and diameter it is 2A, and N1 it is a core refractive index and N2 it is a cladding refractive index. So multimode step gradient index fiber. Then we can go for the comparison. So when you talk about the comparison between step index multimode and the gradient index fiber, the step index multimode fiber, it is bandwidth is very low when we compare to gradient index fiber. In gradient index fiber, bandwidth is higher. Then the diameter of the core in single mode step index fiber, step index multimode fiber, it is 50 to 200 micrometer, but in gradient index fiber about only 50 micrometer. Then application scenario. So when you talk about the step index multimode fiber, it is used for very short distance within kilometers. But here when you go for the gradient index multimode fiber, you can go for more than 10 to 20 kilometers. Then the data transmission from, so here the light propagates in a zigzag path along the step index multimode fiber. Here the gradient index fiber, the light ray travels in the form of sinusoidal because any number of reflections occur during the transmission. Then the model dispersion, in the step index multimodal fiber, it will affect the transmission capacity of the fiber, and because of that, it will have the limit the relay distance. Here, greatly decreased depression than step index multimodal fiber, making a higher bandwidth. Then the numerical aperture of step index fiber is a higher, gradient index fiber it is lower, and the reflection loss is there in step index multimode, and a gradient index multimode there is no reflection loss. And the attenuation point of view, in step index multimode fiber we have maximum attenuation, and when you go for gradient index fiber, the attenuation is the minimum. So thank you all. Thank you for watching this video. Thank you.